Transforming mobility. Glidance and Biped make mobility safer, more intuitive, and profoundly empowering. Speakers: Amos Miller, CEO of Glidance; Mayo Fabian, CEO of Biped. Moderator: Victor Taran, Senior Technical Program Manager of Accessibility, Google.
Hi, my name is Victor Taran, and I would like to start by thanking SciTech Global for giving me this opportunity to moderate this, what will turn out to be a really amazing panel with Amos and Mael, two great companies. We're going to talk about this in a bit more detail just a few minutes later. Amos is here from the Glidance, and Mael is from Biped. But instead of me presenting them or introducing them, I would rather if they introduce themselves in their own words. Who's going to go first? Amos, you started with letter A.
Thank you, Victor, and hi, everyone. My name is Amos Miller. I'm the co-founder and CEO of Glidance, where we're developing a new intelligent guide for people with blindness.
And Mael?
All right, hello everyone. My name is Mael, the co-founder and CEO of Biped Robotics, calling from Switzerland today, where our company is located. And we're also building a mobility device for those who are blind or have low vision.
Thank you both. Really great time for all of us. And I just wanted to add that I myself am completely blind. So to me, hearing from the two visionaries and two leaders in this industry is both personally gratifying, but also, inspiring, because one of these devices, or perhaps even both, are going to change my personal life. So that's, absolutely great to have this opportunity talking to both of you. The first thing I want to start with is the need that you're trying to address with both devices. And I would like you to maybe give a quick introduction into the devices themselves, because I think you talked about the companies in general, but what people might want to hear is what exactly those devices do. But before we go there, I wanted to sort of shed a bit of light on why I think this is so important. I think in the field of blindness, we talk a lot about different issues that blind people face, especially from birth, or people who lost their sight in later life. One of them is literacy, but another big issue is mobility. And I think a lot of blind kids or teachers who work with kids will tell you that mobility is one of the profounding things a lot of blind people have to learn. And if not done right, it may actually impair their ability to later go into professional fields and obtain careers, because if you can't really move around freely and wherever you need to go, whether it's to work or for personal need, that certainly limits the ability of where you can go in your life and with your life. And so I think, to me, seeing both of you trying to address this big need is really, really important. And so I just wanted to have both of you describe maybe in more detail what each device does, so that the listeners and viewers can draw conclusions to themselves as to how you approach the problem of solving mobility for blind people. So maybe I'll start with Mael. If you could talk a bit more about NOAA and Biped in general.
Yeah, absolutely. So I'm probably just going to start by telling the backstory of why we are building this, and that really explains the set of features we came up with. So right at the beginning of COVID, I met a white cane user in Lausanne in Switzerland, heading to the ophthalmic hospital. And he was doing a FaceTime call to a friend. And on FaceTime, his friend was basically telling him to give GPS instructions, okay, at the next intersection, you're going to turn left, right, turn left now. Also giving him some sort of obstacle avoidance pieces of advice, like watch out, you've got stairs to your right. And then also describing where the entrance of the hospital was located. So right across the courtyard, you'll find the entrance with revolving doors, et cetera, et cetera. And just seeing that in action just made me think, well, the person's obviously using a cane and obviously quite an advanced cane user, but to discover new places and to go to new destinations, it's probably like something that is quite challenging. And coming from an AI research background, I was not familiar with the field at all. And I just knew that if we were to build something, we would have to just build it in a very user-focused way. And so we approached the ophthalmic hospital and thought, well, what we noticed was GPS was sort of, not precise enough. The obstacle avoidance maybe needs to act as a complement to what the cane could be detecting on the ground level and detect also head level obstacles or holes or steps that are moving that the cane might pick up too late. And finally, finding things like finding doors, finding crosswalks, etc., etc. And so that's what NOAA stands for in the end. So NOAA stands for Navigation, Obstacle, and AI. And we really try to build it around the cane and around the use of a dog as such. And so just building on top of anything that exists in terms of mobility. And I have a device here. So we basically built a vest. It's kind of a small harness. It's about 2 pounds, so 1 kilogram, worn on the shoulders. It's black on the left-hand side of the chest. We have 3 cameras that have 170 degrees of field of view. And on the right-hand side, we have a small AI computer that runs all the computation, and it basically gives audio feedback to the person. So the person can hear turn right at 2 o'clock, hear beeps when obstacles are coming closer, and then press on buttons that are located on the side to look for specific objects or get a full scene description. That's kind of, in a nutshell, how we approached it and what it currently does.
Very cool. Thanks for spelling the NOAA for me, by the way. I knew the navigation part, I knew orientation. I don't know why I forgot about AI. That's a shame. The AI is the first I sort of remember. Okay, so thanks for doing that, Noah. And thanks for spelling no, I meant to say. Okay, Amos, how about Glidance?
Yeah, of course. Thank you, Victor. And Mael, it's really great to hear your vision and your ideas. And it's just amazing to be in the presence of other collaborators who are together working to address this, what is a very serious problem, like you say, Victor. Mobility, the ability to get around, the ability to impulsively go to places is so foundational to quality of life, to opportunity, to employment. When I moved to London, back when I was like 25, I used to go to, I started a new job. I'm blind myself. I started a new job at a tech company, and I had to commute through London it was like in the middle of winter, cold and dark, and, tapping with my cane, trying to commute and then getting a guide dog. Like you can't have these kind of opportunities without the ability to get around. And our angle at this quest at Glidance is, Mael described how cane users and guide dog users benefit from additional information in order to get around more confidently. I've done a lot of work in mobility, spent a lot of time at Microsoft, built Microsoft Soundscape, which some of the audience might be familiar with. And through my work, I realized that there are still, the fact that we are relying on people being confident with cane users and guide dogs is leaving a lot of people behind, and that there are a lot of people who need more help, especially people who lose their sight later in life. And through my research and exploration, I realized that the information that technology can give the user is only going to be as effective as the way that the information is delivered to the user when they're out there. So if you're going to navigate through a crowded space, move left a bit, right a bit is not going to quite cut it. It's not fine enough. Especially if you're going to provide a mobility aid, which is a primary mobility aid, as an alternative to the cane or the guide dog. And so our work at Glidance is, we concluded that what we need is something that is physically connected to the ground and guides. And that's the essence of Glide. Glide is an autonomous intelligent guide, mobility aid. Basically, it has 2 wheels on the ground, a long handle. You hold on to the handle, you nudge the device forward, and then the wheels begin to autonomously steer the way, a little bit to the left, a bit to the right, guiding you around obstacles, keeping you on a safe path, and guiding you to potential line of sight targets or potentially entire routes as well. And really the goal here is, we have canes, we have guide dogs. I believe that there is a need for another option for people, and that's what we are working on at Glidance.
Yeah, that's really awesome. Thank you both. Couldn't agree more. And this sort of leads me into the next question, which is the approach that both of you took. And I know you kind of both touched on this already, that, you know, obviously, Mael, you were influenced or you were impacted by the person that you met, and sort of we are trying to solve the immediate problem, I guess, they had, which is how do we help someone who already uses the cane, how to augment the cane navigation with something that will help basically bridge the gap, provide information that the cane doesn't. On the other hand, interesting what you mentioned, Amos, about soundscape. And, you know, I'm a user of soundscapes. I'm a little bit biased here, but I do have to say that the ability to, and also actually, Mael, you alluded to that, this audio signals. You know, there's tendency, especially within the last few years, well, not so much few years, maybe a decade or so, to push everything into speech. And the problem with speech, I call it a one-dimensional sort of stream of information, because by the time you hear something spoken, you know, you could be in danger of hitting a tree or falling or whatever, right? And so as important as speech is for us for reading emails or, you know, writing documents, it may not be good enough of means of communication when you need almost instantaneous response, right? Which is where audio signals really become super important, and especially the way that Soundscape solved it by using stereo positioning in headphones. And forgive me, Mael, I don't know if that's the approach that Noah takes, but I find this especially super useful when I don't need to necessarily hear that something left or right. And again, in English, these are short words. I don't know, in other languages, it might sound longer, but, you know, audio signals become really an interesting alternative to speech. But what I'm really also interested to ask you about is, do you have any thoughts as to, and this is not really a competition kind of question, but I'm still curious because in one case, in the case of Glidance, device is standing on the ground, which means it's super convenient, but it also introduces other things, like the user needs to, you know, remember, like if they're in a place where they have to pick it up, or they might be in a place where they need to find a space for the unit to stand, things like that. Whereas in the other situation we have with Noah, the user has to wear something on those shoulders. It might be too heavy. How do you think about ergonomics, you know, for these devices? Because I'm sure there are always pluses and minuses to both. So Amos, do you want to start and talk a little bit about ergonomics? Because I'm kind of curious.
Yeah, absolutely. I mean, you are spot on. I think that there are different technologies and different interfaces that can provide users with different kinds of information: voice, audio, haptics. What I found is that voice and sound and haptics is very good as long as it's used wisely, when you already have your ability to micro navigate. So to use the cane effectively, use the guide dog effectively, orient yourself effectively, and that additional information really enriches your experience. But if you're going to do a viable mobility aid that is going to be the primary mobility aid, for me, I think it's still a way away before we can use wearables for that. I just, and for me, and I often say that once we're able to plug directly into the brain, I think everything will change. But until then, I have, from my experience, my doubts that you can wear something or feel something on your body and you just walk along and be confident that you're not going to trip over anything or walk into anything just without anything in your hand. And so that's really the the essence that Glide is physical. It's connected to the ground. You push against it, it pushes against you, it moves you, you move it. It's very essential to the experience and the confidence and the trust that you build in the device. It's but as you say, for this to be a viable mobility aid, it also has to be light. You have to be able to pick it up. You have to be able to get into a car quickly and easily with it. You can't just expect a forklift to come and pick it up for you and put it in the back of your car every time. Yeah, if you go into a bus or a train, you want to be able to put it in the overhead compartment without concern. You want to be able to walk in rough terrains, smooth terrains, all kinds of requirements that just are just essential to have this as a viable physical device that is guiding you. So these are really the constraints and the requirements that I believe are essential if we're going to bring about a mobility aid of this nature at this stage.
Very cool. Thank you, Mael. What are some of your thoughts?
Yeah, I mean, I think Amos pointed it out very well. I think if you want to do a primary mobility aid, I also don't believe in the aspect of having something like Noah, for example, give a continuous sound that you have to follow. That would be way too overwhelming, and it's been tried and researched over a couple of devices, and it just doesn't work as such. And this is where I think the positions of like the angles we took are very different, having one be a primary mobility aid as a replacement and the other in addition to a primary mobility aid. And that's also one of the things in terms of, I think, two aspects to the ergonomics of what we design is, of course, like the form factor, and there's the audio interface. And what we realized over the test sessions is that we really needed to be very sparse, like only throw in the essential information that is needed at a specific moment and avoid overwhelming the user at all costs. And so that's like, we've spent probably 2 years roughly just building, like a trajectory prediction model that looks at the dynamics of the scene and if someone's about to collide with you, et cetera, to just be able to filter more sounds and not overwhelm the user with this. But otherwise, the risk of overwhelming someone with a continuous sound, for example, is very high. And then for the hardware, I think, of course, there is hardly like a one solution fits all. I'm just glad there's like more and more companies in this field that are building alternative ways to wear the device. And embed technologies on the shoulders or like forehead or belt or whatever. We tried the belt in the very first place, but then we quickly took it for a spin and realized, well, the cameras are half of the time like blocked by the hand of the user, who's either like a guide dog or a white cane user. And so we went on the chest level, and that's where we got the first success. But it was like a GoPro clip, and that was really hard to like when you have straps and everything to clip. I really think this is too much of a hassle to put in the first place. And so that's how we came to this form factor. The head mounts, we are not so sure it's really worth investing a lot of time and money in like a head mount, and rather like wait for smart glasses to have like day and night vision with 3D sensors and everything. That's gonna come one day. It's still super challenging. But yeah, like the shoulders felt very natural for to build this complement to canes and dogs.
Yeah, very cool. Thank you, and thank you for describing your thought process, because that's also I'm also a technologist, and always this is one of the interesting aspects to me. How do we arrive at a certain invention, right? Obviously, it takes phases, it takes thinking, it takes trial, it takes failure, and so thank you for pointing out that you guys went through several iterations before you got to where you are today. And one other thing that I do want to point out, because I think it's important to me personally also, what both mobility aids allow us to do is to travel spontaneously. Because so my wife and I would travel quite a bit, at least we go to one destination, we try to go every year somewhere, different country. And most of blind people, the way we're taught, like, oh, you need to go from point A to point B, right? Like mobility instructor shows you, you start here, then you remember your route, whether it's to work or to your grocery store or whatever. But whenever you travel, you hear oftentimes sighted people who say like, oh, and we went there and we saw this, and it's like, oh my God, it would be so cool, like if just somebody dropped me somewhere on some random street, and I would like to be able to explore what's around me without having always to plan for something. And I think this is where I would like, hopefully this technology is going to get us to, is this ability to really travel spontaneously, get to necessarily unplanned places, things like that. And so this kind of leads me to the whole idea of, I know this is, we could talk about this for another hour, but both devices rely on AI quite a bit. And could you both quickly talk about what role does AI really play in both devices? I know we could talk about, there's AI as an AI, and there's trendy AI, and there's a real AI. But if you look at both devices, what role does AI really play in both of them? I don't know. I want to start with Mael, maybe, because you guys have an AI button. So talk about that.
Yeah, no, absolutely. So I think there's for us, we're leveraging the field of AI, mostly focused on computer vision, to both do a scene description. So that's, you can really think of it as a left to right. That's why we have such a wide field of view camera. So you can really do like a full description to really grasp what your surroundings are like, what are the key elements that are useful for mobility, but also to discover the place. And so for that one, we have like a big silver button in the middle of the piece that goes on the right-hand side of your chest. And then more specifically on the right edge of the device, then you can look for specific elements. These are like object recognition models. And of course, like you can look for doors, you can look for crosswalks or stuff like that. But I think this blend of like this mix of models that run on the edge, meaning in the device locally, that do not require internet connectivity. And for the things that are super demanding in terms of computing resources, use AI that is connected on the cloud is a pretty relevant solution so far. And then that's how we're building it. Of course, like when you look at, I think no longer than last week, OpenAI released the real-time API, which is quite literally around the corner, like being able to do a speech-to-speech, but also ingesting like a video feed in the middle, so you can ask questions as you walk in the street, for example. I think this is really where the technology is going, and this is what we have in mind for the next few steps, is really going into video description. By the time this video airs, that the feature would probably already be released. So you can think really of it as a AI narrator that's talking as you walk for really this exploration. Like you're not really traveling somewhere with a specific destination, but you're relying on a voice that's gradually talking and highlighting the key elements in the street.
Sounds great. Thank you. I just want to pass it over to Amos to share some, because you guys have robotics and AI and everything in between. So,
absolutely.
So maybe you could talk like for a minute or two about that.
Yeah, just to be brief. We have, so Glide is powered by 2 depth stereo cameras and at the handle, and a bunch of other sensors on the device, so that it can really have a good detailed understanding of its immediate surrounding and the long range as well. And we use our proprietary AI is mainly around what is a system that we call sensible wayfinding system. And this is a system that's based on computer vision and local maps and priors and foundational models that enable the device to make sense of the environment and help the user make sensible navigation decisions. I'll give you an example. I mean, it might sound obvious, but you know, for computers, nothing is obvious.
Yeah.
If you walk along a corridor and the corridor is going to turn to the left, and the computer can't see through the wall, so it doesn't know that the corridor continues there, something needs to give it the belief that, based on what I can see, the corridor does continue over that direction. Yeah, and so the AI, the sensible wayfinding platform that Glidance is investing a lot in, is really enabling Glide to make sense of environments and help the user make and actually guide the user sensibly in a space. The other aspect is exactly what Mel talked about. The potential and opportunity for the human-computer interaction, right? The voice, the instant understanding of a scene and an environment. And I think that's really where the magic happens. It's a combination of that really responsive, interactive interface that allows me as a user to understand what's going on around me, and the robot making sensible navigation decisions.
Sounds great. Thank you both. And maybe quickly, if you could just share the websites where people can find more information about both devices. Amos, you want to go first?
Yeah,
please?
so our website is glidance.io. It's the word guidance with the U switched with an L, so glidance.io. We have extensive community engagement sessions and people who are interested to follow what the development of Glide. We are still about a year away before the device ships, and we really strongly encourage people to go onto the website, sign up, take part. We're building this future together, and in these kind of sessions, these are the best places to engage and bring people on board.
Very cool. Glidance.io and Mael?
Yeah, our website is biped.ai. So that would be spelled BIPED.ai, like a bipedal.ai. And our devices available usually within 6 to 9 weeks, but most people actually want to try it, and they're right to do so. So Marco, who's our COO, is usually the one on the roads in the US. So yeah, we have a couple of distributors, so people can just reach out to us, and we just find the nearest distributor to schedule a test.
Sounds great. Exciting times ahead. Really looking forward to this technology disrupting mobility and making blind people and people with visual impairment more productive. And so we can finally go to places. Thank you both for this wonderful panel. And thank you, SciTech Global, for, again, giving me this opportunity to talk to these two wonderful, amazing, inventive people.